The main point of the pilot was to understand chronic arsenite-induced carcinogenesis in BS2B cells transformed for 6 months by arsenite, and they're called BAST cells at that point. But instead of the usual 2D cell cultures, we were going to establish BAST spheroids, organotypic cultures, to define metabolic programming and protein regulators using new technology for a step closer to the tumor microenvironment. Now, the major pieces in our report is EZH2, which catalyzes the trimethylation of histone H3 adenosine. But most important to this is that it's critical to cancer initiation and progression, and is frequently overexpressed in lung cancer. And this is from our own in-house RNA-seq data, as well as some literature, as well as for many other human cancers. GAB is an inhibitory neurotransmitter that also modulates inflammation implicated in human cancer in various ways that's described in the report. Another piece that's important is multiple stabilized slope-resolved metabolomics. We are the pioneers in this area that can trace in metabolism in great detail, especially metabolic reprogramming in cancers, and reverse phase protein array, which is an antibody-based array method that can query many proteins all at once. So what we did in our pilot was the confluence of 3 different advances. One of them was from the literature and our own evidence of EZH2 modulating GAB signaling in the tumor microenvironment, and a success in organotypic culture, compatibility with MSERM, and a great expansion of our crowdsourced RPPA capability. Now, EZH2 interacts with GAB in regulating lung cancer cell proliferation in 2 different ways. It negatively modulates endogenous GAB metabolism to attenuate cell growth, as well as interacting with GABAergic signaling to stimulate cell growth. Now, I don't have time to obviously explain this complex diagram, but the point is that most of these proteins, these genes that you see, it comes from RNA-seq data from our own study on 75 pairs of matched cancer and non-cancer lung tissues from non-small cell lung cancer patients. This slide shows how cancer tissues overexpress GAB in various ways. On the left is a UK022 real patient organotypic culture media, and on the right is a regulatory T cell media. And in both cases, they were given carbon-13 labeled glutamine, and you see the new synthesis of GAB and glutamate from glutamine in both cases, and this is measured using NMR. This figure shows how RPPA can give most of the proteins involved in that earlier diagram that I showed you of the interaction between EZH2 and GAB. Now, in this figure, obviously, you're going to have to refer to the report for details, but this is basically showing how stabilized slope-resolved metabolomics can trace the differences and changes in purine nucleotide metabolism, looking at the interaction between EZH2 and GAB. So we were able to incorporate all of these above slides and more into an R01 grant proposal that we wrote to NCI. And we are continuing on moving this capability into platforms on the BS2B and BAST cells to work with arsenic effects.